Hello viewers, welcome to Finite Element Analysis. Today we are going to discuss Rayleigh Ritz method example problem. In this problem, we are going to determine the deflection of simply supported beam. Load is uniform distributed load over through the span. Example problem of Rayleigh Ritz methods. A simply supported beam subjected to uniform distributed load over entire span. Determine the bending moment and deflection at mid-span by using Rayleigh Ritz method and compare with the exact solution. A simply supported beam, both end is fixed. The boundary condition is at A is x equal to 0. At B support x equal to L. So the bending moment is at A and B, that deflection is 0. So the bending moment deflection is, it is a parabolic curve. In this problem, we have to determine the deflection and the bending moment at the midpoint, mid-span. Then the second question is asking compare with the exact solution. So the Rayleigh Ritz method have totally 6 steps. The first step is we have to set the approximate function, say either polynomial or trigonometry. Polynomial trial function equation is y equal to a0 plus a1x plus a2 x power 2 plus a3 x power 3 and so on, a power an x power n is the either polynomial equation or trigonometric equation we have to set initially. The trigonometric function is y equal to a1 sin pi x divided by L plus a2 sin 3 pi x divided by L plus a3 sin pi phi x divided by L. So from either polynomial or trigonometric we have to set trial function solution initially. The step 2, it is the Rayleigh Ritz method based on this potential minimum potential energy approach. The potential energy equal to strain energy minus what is the x load is acting on the systems, that is strain energy my external load is acting at the beam. Strain energy is U equal to EI divided by 2, the integration of 0 to L, that is a entire the span, starting point to the end of the length of the span. So d square y divided by dx square whole power square dx. This is the second step. Third step is we have to determine the step number 3 is work done at the systems. So H notation is H, integration of 0 to L domain W y dx. The W will be indicate the what is the load acting on the beam. In this beam uniform distributed load is acting entire the span of the length. So y dx. The next step is so total potential energy, strain energy minus work done. The fifth step is we have to determine the Rayleigh Ritz parameter. Rayleigh Ritz parameters a1 and a2. So a1 and a2. So from the trigonometric function a1 and a2 we have to determine by using a partial differential equation with respect to a1 and a2 parameters. So dou y divided by dou a1 equal to 0, dou y divided by dou a2. If you are increasing the parameter a1 and a3, so a3 means so dou y divided by dou a3. So when you are increasing the parameter a1, a2, a3, a4, your result value will be accurate, it will be matching with the exact solution. The last step is after determine the Rayleigh Ritz parameter a1 and a2, we have to determine the deflection and bending moment and stress we can calculate. This is that Rayleigh Ritz method. Totally 6 steps have. First step is we have to set the approximate solution, either polynomial series or trigonometric. Then we have to determine the strain energy equation, then work done, then minimum potential, total potential energy is strain energy minus work done the system. Then fifth step is we have to determine the Rayleigh Ritz parameter A1 and A2 by using a partial differential equation. The last one is from that A1 A2 we have to substitute in the trial function equation. Then we have to determine the deflection bending moment we can calculate. In this problem, I am going to using a polynomial series, trigonometric series I am going to select. To make this series more simple, let us consider only two terms, y equal to a1 sin pi x divided by L plus a2 sin 3 pi x L. This is that we have to a1 a2 are Ritz parameter we have to determine based on a Rayleigh Ritz method by using a potential energy approach. The first step, so from that total potential energy of the beam is pi equal to strain energy minus work done by the external force. So strain energy equal to U equal to EI divided by 2 integration of 0 to L d square y divided by dx square whole power square dx. From that, so trigonometric equation y equal to a1 sin pi x divided by L plus a2 sin 3 pi x divided by L. From that we have to differentiate that this equation two times, dy by dx. A1 is constant, sin differentiate cos pi x divided by L. So pi x divided by L is this constant pi divided by L. A2 is constant, same we have tried. Then sin is cos 3 pi x divided by L into 3 pi divided by L. So simplify this equation, constant term separately we have to take a1 pi divided by L cos pi x divided by L plus similarly a2 3 pi divided by L cos 3 by x divided by L. So first differentiate we have to complete, then second differentiate the above the equation d square y divided by dx square. So cos differentiate is minus sin x. So the common term is constant a1 by divided by L rewrite, then cos is sin by x divided by L into pi divided by L differentiate, then minus similarly a2 3 by divided by L sin 3 pi x divided by L into 3 by divided by L. So finally we have to simplify these common terms, minus by pi square into L square sin by x divided by L minus a2 similarly 3 pi into 3 pi, so 9 by square divided by L square sin 3 pi x divided by L. So finally we are getting a equation number 4 is we are determining the d square y divided by dx square. So minus a1 by square divided by L square sin by x divided by L minus a2 9 by square divided by L square sin 3 by x divided by L. The next step, so we are determined that simplify this above the term. So we are getting a d square y divided by dx square equal to minus a1 by square divided by L square sin pi x divided by L minus a2 9 by square divided by L square sin 3 by x divided by L. We have to substitute in the d square y in the equation number 3. Equation number 3 is, so EI divided by 2, integration of 0 to L, so d square y divided by dx square, already we simplified this term, minus a1 by square divided by L square, sin by x divided by L, minus a2 9 by square divided by L square, sin 3 by x divided by L the whole square into dx. So both the negative sign we have to remove from this equation, take it outside, so positive sign will come in this equation. So a1 by square divided by L square, sin by x divided by L, plus a2 9 by square divided by L square, sin 3 by x divided by L whole square dx. So this is, so we are again we are going to integrate this. Before that, this is a plus b whole square term have. So we have to simplify this one is, we are taking a by square and L square we are taking outside common term, the constant pi 5 power 4 L power 4 0 to 1, well, integration of 0 to L. So a1 sin by x divided by L plus 9 2 into is here 9 a2 sin 3 by x divided by L whole square. So this is that we are considering a plus b whole square, a square plus b square plus 2ab. Using this formula we have to expand this term is a1 sin square by x divided by L plus 9 is square is 81 a2 square sin square 3 pi x divided by L 2 into ab. So 2 into a1 sin pi x divided by L into 9 a2 sin 3 by x divided by L and dx. So simplified this, u equal to ei by 5 power 4 L power 4 integration of 0 to L. So a1 square sin square by x divided by L plus 81 a2 square sin square 3 pi x divided by L plus 2 into 9 18 a1 a2 sin pi x divided by L sin 3 by x divided by L and dx. This is equation number 5. So next step is we have to determine the integration of individual term, integration of a1 square by x divided by L, the integration of 0 to L 81 a2 square sin square 3 by x divided by L. The third term is we have to determine 0 to L, the integration of 0 to L 18 a1 a2 sin by x divided by L sin 3 by x divided by L. So each 3 term we have to calculate. After that we have to apply the a1 and a2 parameter we have to determine. The next step is, so we have to calculate the individual 3 term we have to calculate by using integral approach. So integration of 0 to L a1 square sin square by x divided by L dx. So sin square x equal to 1 minus cos 2x divided by 2. So the common constant 1 by 2 I am taking outside, 1 minus cos 2 by x divided by L into dx. So a1 square, this constant half I am taking outside, integration of 0 to L 1 minus cos 2 by x divided by L dx. So a1 square divided by 2, I am putting the integral form inside the equation. So 0 to L dx, integration of 0 to L cos 2 by x divided by L into dx. So integrate the above the term and substitute the limit value. So integration is dx is x, limit value is 0 to L. Similarly sin 2 by x divided by L, integration is so 2 by divided by L 0 to L. Then substitute the limit value. Actually sin 2 by equal to 0, sin 0 equal to 0. So L substitute the limit value 0 to L, L minus 0 minus L divided by 2 by sin 2 by L divided by L minus sin 0. So finally we are getting a value is a1 square into L divided by 2. The first term we are determining is value is a1 square divided by L divided by 2. This is equation number 6. So we are determining this the first term. The next term is we are going to determine the 81 a2 square sin square 3 by x divided by L. 0 to the limit value is 0 to L. So sin square x equal to 1 minus cos tx divided by 2. So 1 by 2 is common, this constant I am taking outside. So 1 minus cos 6 pi x divided by L. So 3 is 2 into 3 is 6 pi x divided by L. So integral this term is I am putting a integral into the inside the equation 0 to L dx minus 0 to L cos 6 pi x divided by L dx. So finally I am getting a values 81 divided by a2 square divided by 2. The integration of this above the value is x, limit value is 0 to L. So integration of sin 6 pi x divided by L divided by 6 pi divided by L, limit value is 0 to L. Substitute this value, finally I am getting this actually sin 6 pi equal to 0, sin 0 equal to 0. So finally I am getting a value is this term is 0, finally L 81 a2 square into L divided by 2. This equation number is 7. So actually we are determining the equation number 6, equation number 7, then equation number the last third one is we have to determine integral individually. So individually 0 to L 18 a1 a2 sin by x divided by L sin 3 pi x divided by L equal to 81 a2 0 to L sin, actually sin a we are considering a sin a sin b. So cos a minus b minus cos a plus b divided by 2. So 18 a1 a2 0 to L sin 3 by x divided by L sin by x divided by L. So 18 a1 a2, apply the sin a sin b formula. So I am getting a 1 by 2 and taking outside. So cos 2 by x divided by L minus cos 4x divided by L into dx. So finally I am getting a simplified this equation is 18 a1 a2 divided by 2 integration of 0 to L cos 2 by x divided by L dx minus 0 to L cos 4 by x divided by L dx. So integration of this above the term is, so cos is sin 2 by x divided by L, 2 by divided by L. So minus 0 to L L dx. So 18 a1 divided by 2, the integration of the limit value 0 to L. After substituting the limit value, and finally that the third time is I am getting a sin 2 by equal to 0, sin 4 by equal to 0, sin 0 equal to 0. So for the last third term is getting a answer is 0. This is equation number 8. So finally we have to substitute this all the term is in the equation number 5. So equation number 5 is ei divided by 2 by 5 more divided by L power 4. So equation number 6 is a1 square divided by L divided by 2. Equation number 7 is 81 a2 square divided by L divided by 2 plus the third term is 8th equation is 0. So finally we are getting a strain energy is simplified form U equal to ei by power 4 L divided by L power 4 81 square plus 81 a2 square. Strain energy is equation number 9. We determine the strain energy. The next step we have to determine the work done by the external force. So work done by the external force, we know that integration of 0 to L W into y dx. So already y is, we know that trigonometry series is a1 sin pi x divided by L plus a2 sin 3 pi x divided by L. So a1 and a2 we have to determine by using a work done by the external force. So we have to integrate the term 0 to L a1 sin by x divided by L plus a2 sin 3 by x divided by L into dx. So integral to the individual term. So then substitute the limit value 0 to L. Integration of sin pi x divided by is cos minus cos by x divided by L pi divided by L. Similarly, minus cos 3 by x divided by L divided by 3 by divided by L. The limit value is 0 to L. Substitute this limit value. Actually, cos 0 equal to 1, cos pi equal to minus 1, cos 3 pi equal to minus 1. So substitute this value, cos pi x divided by L 0 to L limit value minus 1. Similarly a to L divided by 3 pi, so minus 1. So finally we are getting a 2a1 L divided by pi plus 2a2 L divided by 3 pi. So we are getting a value is 2w L divided by pi a1 plus a2 3. This equation number 10. So now we are determining the strain energy we are calculated and work done by the external force H we are calculated. The potential energy is pi equal to U minus H. The next step is total potential energy is strain energy minus external work done by external force. Substitute this all the values. Strain energy is ei by 4 divided by 4 L cube a1 square plus 81 a2 square minus work done by external force is 2WL divided by pi a1 plus a2 divided by 3. This is equation number 11. For stationary value of pi, the following condition must be satisfied. Tau pi divided by tau a1 equal to 0 and tau pi divided by tau a2 equal to 0. We have to calculate the Rayleigh Ritz parameter a1 and a2. So differentiate the equation with respect to a1 and a2. So tau pi divided by tau a1. So this is the constant term ei by 4 divided by 4 L cube. So 2 into a1 The 81 a2 is this term will be 0. This constant term will come minus 2 e wgl divided by pi. So this is 1 will come, this is 0 will come. So 2 wl divided by pi. Simplified this term is equating this term is 2 pi 5 4 l cube 2 a1 equal to wg l divided by 5. From this a1 we have to calculate. A1 is so actually ei by already on pi is there, so pi by 4 into pi is pi power 5 4 w l power 4 a1 we are calculate. Similarly another Ritz parameter is a2 we have to calculate. Similarly tau y divided by tau a2. So from this the constant is ei by 4 l cube in actually 2 into 81 162 a2. Similarly minus 2 wl divided by pi. Say a1 is constant, this is 0, so a2 is 1, so 1 divided by 3. From that we are calculating this a2 Rayleigh Ritz parameter. Second parameter a2 is 4 wgl power 4 243 ei pi power 5. The next step we have to substitute this value of a1 a2 in the equation number earlier equation number the trial function equation y equal to a1 sin pi x divided by l a2 sin 3 pi x divided by l. Substitute this a1 a2 parameter. This is a1, this is a2 parameter. Substitute this value. So we have to determine the maximum deflection at occur is x equal to l by 2. The entire span length is l, so mid span is l by 2. So l by 2 we have to substitute in y max equal to the 4 wgl4 ei pi power 5 sin pi x x equal to we have to substitute l by 2 divided by l 4 wgl power 4 243 I pi power 5 sin 3 by x is l by 2 divided by l. So sin pi divided by 2 l the both l will be cancelled. So finally that sin pi divided by 2 equal to 1, sin 3 by divided by 2 equal to minus 1. Substitute this value is sin pi divided by 2 is 1, so 4 wgl power 4 ei pi power 5 minus sin 3 pi divided by 2 is minus 1. 4 wgl power 4 minus divided by 243 ei pi power 5. So e of simplified this term. So finally y max equal to 0.0130 wgl power 4 divided by ei. This is equation number 13. So we are simplified this term is 4 wgl power 4 divided by ei pi power 4 0.9952 equal to 3.92 wgl power 4 ei pi power 5. So we know that from the strength of material we are calculate this y max is pi divided by 384 wgl power 4 divided by e divided by wgl power 4 divided by I. So from the equation number 13 equation number 14 we know that exact solution obtained by using Rayleigh Ritz method are same. This both equation are same. Similarly the next step is bending moment we have to calculate at the mid span. We know that bending moment is m equal to ei d square y divided by dx square. This is equation number 15. So d square y divided by dx square, already we calculated the value is a1 by square divided by L square sin by x divided by L plus a2 9 by square divided by L square sin 3 by x L. Substitute this a1 and a2 parameters. So finally we are getting a d square y divided by dx square minus 4 double g L power 4 divided by ei pi power 5 into pi square L square sin by x divided by L plus 4 double g L power 4 243 ei pi power 5 into 9 pi square divided by L square sin 3 pi x divided by L. So maximum bending moment occurs at x equal to L by 2. So substitute this x equal to L by 2. So finally we are simplify sin pi divided by 2 is 1, sin 3 pi divided by 2 minus 1. Substitute these values. So minus 4 double g L power 4 by square ei by pi L square into 1 plus 4 double g L power 4 243 ei pi power 5 into 9 by square divided by L square. So sin 3 by 2 equal minus 1. Simplified this. So we are getting a minus 4 double g L square by square ei pi power 5 minus 36 double g L square by square divided by 243 ei pi 5. So minus term we are going to put it inside, minus, then minus into minus plus, minus 4 double g L square divided by ei pi power 3 plus 36 double g L square divided by 243 ei pi 3. So minus 4 double g L square ei divided by pi power 3 plus 36 divided by 243 0.148 ei pi cube double g L square. So again I am going to simplify this both term, minus 3.852 double g L square ei pi power 3. So we are determined the d square y divided by dx square value we calculated, that is minus 0.124 double g L power 4 divided by e into I. So we have to substitute this d square y divided by dx square in the equation number 5. Bending moment equation is m equal to ei d square y divided by dx square. So substitute this value is ei minus 0.124 double g L square divided by ei. So maximum bending moment at center point is minus 0.124 double g L square. So the negative sign indicate the downward load. So we know that for simply supported beam subjected to uniform distributed load, maximum bending moment load is at the mid span is double g L square divided by 8. So 0.125 double g L square is exact solution. From equation number 16, maximum bending moment m equal to minus 0.124 double g L square. The equation number 17, maximum bending moment at midpoint is 0.125 double g L square. So from the equation number 16 and 17, we know that exact solution and solution obtained by using Rayleigh Ritz method are almost same. In order to get accurate result, more time in Fourier series should be taken. Thank you for watching my video.